Welcome back to another video for the cheat sheet series. In this video, we'll be looking at solving a particular Sturm-Liouville problem that you will frequently run into when solving PDEs. So might as well just solve them in this video so we don't have to go through the process many times in our journeys through solving these PDEs. Additionally, because they appear so often, you can put them in your cheat sheet and it will be a quick and easy way to jump into the solution and reduce the time in solving these PDEs. So let's get started. In this video, we are given an ODE of phi double prime of x plus lambda phi of x is equal to 0. So for those of you who do not know, this is actually a Sturm-Liouville problem. And we'll discuss that more later in the PDE series. But let's just look at this as a regular ODE from the intervals of 0 to L. And lucky for us, we already have the solution with its derivative. So we have pretty much the general solution, and it wants us to find the particular solution P of x for these 4 different types of cases. So we're going to be tackling down all 4 cases, and we're going to start off with the first one. So for the first one, we are given P0 is equal to 0, and then P of L is equal to 0. So we are going to look at this portion here, and we can see that it has 3 types of solutions depending on whether lambda is negative, lambda is equal to 0, and lambda is greater than 0. And so our goal for this is to find what phi of x is, that it's not the trivial solution. So the trivial solution is actually when phi of x is equal to 0. And we don't want that. We want phi of x to be something else that is not 0. So for this one, we are going to start off with the negative case. Well, actually, we're just going to plug in phi of 0 for all of them. So when phi is equal to 0, we will get a terrible line. A hyperbolic cosine of 0 plus b hyperbolic sine of 0, and then this one would just be a, and then this would be cosine of 0 plus sine or b sine of 0. And again, it's for lambda is negative, lambda is 0, and then lambda is greater than 0. And so what do we get here? So if we remember how to use trig, sine of 0 is just 0. And then for hyperbolic trig function, hyperbolic sine of 0 is also equal to 0. For cosine of 0, well, that's just 1. Same thing applies with hyperbolic cosine. And so what we're left here is all of this is just equal to a. And we want this to equal to 0. And so the only way this is true is if a is equal to 0. So that's okay because we also have b. So this doesn't necessarily give us a trivial solution yet. But let's continue on with plugging in the second condition. So for this case now, when phi is equal to L, or L is just any arbitrary value, we will get b hyperbolic sine of the square root of negative lambda times L. This would just be b. This would be b sine of the square root of lambda times L. Again, this is for negative, this one's 0, and then this one is greater than 0. So obviously we don't know what hyperbolic sine of square root of negative lambda L is, nor sine of square root of lambda times L is. But we can find a solution for this. So let's start off with the first case. So for the first case, this will only be equal to 0 when hyperbolic sine the square root of negative lambda of L is equal to 0. Or, more specifically, if the square root of lambda is equal to 0 because of how the hyperbolic sine function looks. So for those of you who don't remember, the way the hyperbolic sine function is graphed is kind of looks like a trig function, but it really isn't. And so we know that there's only one solution when it's equal to 0. And so because the square root of negative lambda must be equal to 0, this tells us that lambda must equal to 0. But we can't have that because we already know that this is the case when lambda is equal to a negative value. And so what this tells us, this forces us to make b equal to 0, and this will give us a trivial solution. So we don't want that. Like I said, we don't want trivial solution. We want a particular solution. So this part is no good. Same thing goes for the second case when lambda is equal to 0. This forces us b to be 0 in order for this to be true. And so again, this one does not work either. The last case, which is, I'm pretty sure it's going to be pretty obvious that this case has to work. So for this one, for this to equal to 0, sine of square root of lambda of L must equal 0. So this means the square root of lambda times L must be equal to 0, or not 0. If you know how a sine function looks, this will be for every n pi intervals. And so because when we look at our sine graph, we will see that it occurs at every pi value. And so what this now tells us is that lambda will be equal to, well, it won't be lambda, there'll be infinite solutions for this one because sine goes on forever. So there's going to be a lambda with a subscript of n of n pi over L quantity squared. And so for our solution for the first part, we will have phi of x is going to be equal to b times sine of square root of lambda L, where the square root of lambda is equal to, not square root of lambda x, where square root of lambda is equal to n pi over L. And this is only true for this particular case. So now for the other three. So the other three will pretty much be a similar process, and because we have, for part B in this case, for part B, because we already looked at the phi of 0 is equal to 0, then we can completely skip that step because we know when phi of 0 is equal to 0, this forces us for a to be equal to 0. So now we have the phi prime of L that we have to solve for. And this will give us, again, 3 cases. And so for the first one, it'll be the square root of negative lambda b hyperbolic cosine of the square root of negative lambda. That's terrible. There you go. L. So this for lambda is less than 0. Then we have b, and then the square root of lambda cosine of the square root of lambda L, and then lambda is equal to 0, and then lambda is greater than 0. Hi, so this is post-production me, and while we were almost finishing up with this video, it started to get really choppy, so I decided to just cut this off and redo it. So I'm just going to go ahead and finish this example for part B more specifically, and then we're going to do part C and D in a separate video. So last time we were able to get a somewhat of a solution when we plug in phi prime of L, and so now all we have to do is figure out which of these 3 solutions is actually valid. So for the first one, let's just start with the most obvious one, the second one, we can see that V's prime of L is equal to B, and we want this to be equal to 0. So this only tells us that B is equal to 0. So right then and there, this gives us a trivial solution, so this is not a valid answer. The first one, for this to be equal to 0, what we want is hyperbolic cosine of the square root of negative lambda times L to be equal to 0. And this is pretty much impossible because the way the hyperbolic cosine function is, it doesn't have a 0. There's no 0 point. So this means that this can't be equal to 0, forcing us to make B equal to 0. And again, this is going to give us the trivial solution, so this is also an invalid answer. Now our last one, so the same thing happened with part A. Our last one, it's our only hope. We have to have a non-trivial solution. So this one, for this to be equal to 0, we want cosine, and I forgot the B here. We want cosine of the square root of lambda times L to be equal to 0. And this will only hold true if the square root of lambda times L is equal to n minus 1/2 times pi. So more specifically, our lambda is going to be an infinite number of solutions. So it's going to be lambda of n is going to be equal to n minus 1/2 pi all over L, and the entire thing squared. And so this is giving us a non-trivial solution. So that means that our solution for phi of x with the condition of phi of 0 is equal to 0 and phi prime of L is equal to 0, it is sine times the square root of lambda of n times L, not L, times x, where square root of lambda of n is equal to n minus 1/2 all multiplied by pi all divided by L. And so that's pretty much it for part B. Like I said, part C and D will be in another video. And so thank you guys for watching, and I'll see you in the next one.